Hey guys, this is part 2 of the June 2017 AQA Further Maths paper 2. So it's calculator paper. We've got up to question, we finished on question 8. We're going to start at question 9 and hopefully do the next 8 questions. So, question 9 is inequalities. We've got these two inequalities. Minus 11 is less than 5x is less than or equal to 5, and 6x plus 7 is less than or equal to 4x plus 4. We want to show that there is only one single integer that x can be to satisfy both of these inequalities. So, how are we going to do that? Well, we're going to solve each one. So the guy on the left, we just divide through by 5. So we would get x is less than or equal to 5 divided by 5 is 1, but strictly greater than minus 11 divided by 5 is minus 2.2. Okay, so that's the left inequality taken care of. And the guy on the right, let's change colour. Okay, for the guy on the right, let's first of all take 4x from both sides. So then we're going to get 2x plus 7 is less than or equal to 4. If we then take away the 7, 2x is less than or equal to minus 3. If we divide by 2, x is less than or equal to minus 3 over 2, which is minus 1.5. So x is less than or equal to minus 1.5. Now if we list our integer solutions, for this guy on the right, in terms of integers then, x can be minus 2, minus 3, minus 4, blah blah blah, keeps on going down. If we list the integer values on the left, well, x can be, or it has to be greater, minus 2.2, so it can be minus 2, or it can be minus 1, 0, 1, but only one value pops up in both inequalities, and that is minus 2. So to satisfy both of them, x can't be minus 1 or 0 or 1, and it can't be minus 3, minus 4, etc. X can only be minus 2. So x has to equal minus 2. Jobs again. Okay, question 10. We've got ABC as our isosceles triangle with AB equal to AC. We're told the area of the triangle is 57.76 centimeters squared. We've got this one angle of 150 degrees. We want to work out the length of AB. So, AB and AC are the same length because it's isosceles. We don't know them. Let's call them X. Now, we can find the area of a triangle when we know an angle and the two side lengths coming out of that angle. So, by that, the formula is area equals 1/2 AB sine theta. So if we put our stuff in here, we're going to get 1/2 x squared times sine 150. Then we know that that is equal to 57.76. So we then need to solve this for x. So if we multiply by 2, we get x squared sine 150 is 2 times 57.76, whatever that is. Then divide by sine 150, then we're going to get x squared is equal to 2 times 57.76 all over sine 150. And then finally, to get what x is, square root all of that. So the square root of 2 times 57.76 divided by sine 150, and we will get x equals 15.2 centimetres. Jobs again. Okay, question 11, we've got a lovely piecewise function that we want to draw the graph of. So, we're going to do this one function, or one bit of the function, at a time. So, the first one then is f of x is 3 minus 2x. For x greater than or equal to minus 2, strictly less than 0. So this guy is a straight line. Let's find the coordinates of each end of the line. So, first of all, if x, let's try that again. First of all, if x equals minus 2, then we've got 3 minus 2 times minus 2, which is 3, add 4, we get f of x equals 7. So there's one coordinate we want to plot, minus 2, 7. And then when x is 0, we get 3 minus 2 times 0, so we just get 3. So f of x would equal 3. So we've got that coordinate as well, 0, 3. Now remember here, we need to use inequality notation as well to fit in with the inequalities. So x is allowed to be minus 2. So down at minus 2 we're going to use a hollow dot. Sorry, a coloured in dot. But x is not allowed to equal 0. So for that coordinate point, we're going to use a hollow dot. So that first bit of our graph is going to look like that. So again, we've got a coloured in dot down at minus 2, 7, because x is allowed to equal minus 2. But then we've got a hollow dot here at x equals 0, because it's not allowed to equal 0. Okay, on with the next. Okay, the second function is a quadratic. So 1 plus x times 3 minus x. If we expanded all of that out, that would give us an unhappy quadratic with a negative x squared term. But we're not going to do that. So this function is for x greater than or equal to 0, strictly less than 4. So first of all, if we substitute in x equals 0, we get 1 plus 0 times 3 minus 0, which is 1 times 3, which is 3. So there's our first point to plot, 0, 3. Now we actually plotted this for the first one, where we had a strict inequality. For the quadratic one though, it's an or equal to inequality, so now we can colour that dot in. Okay, so that's that first blue dot there. Then the next coordinate point I would plot is the other end of it. So when x is 4, we get 1 plus 4 is 5, 3 minus 4 is minus 1. We get 5 times minus 1. So that gives us minus 5. So another point we can plot is 4 minus 5 again. That's a strict inequality. So for now I'm leaving it hollow. So that circle down there is the point 4 minus 5. And then really I guess we should substitute in all of the values between 1 and 4. Just the integer values there. So when x is 1, we're going to get 1 plus 1, which is 2 times 3 minus 1. 3 minus 1 is 2. 2 times 2 is 4. So there's our next point to plot then, so let's go down and do that. So 1, 4 is this point right there. And then let's substitute in x equals 2. So when x equals 2, well, 1 plus 2 is 3. 3 minus 2 is 1. 3 times 1 is 3. So, there's our next point to plot. When x is 2, f of x is 3. Okay, so let's go down and do that. So 2, 3 is this point here. And then we need to do one more. And x is equal to 3. So when x is equal to 3, 1 plus 3 is 4. 3 minus 3 though is 0. So we're going to get the point 3, 0. Which I've already done. Okay, so now we need to join those points up. If I try and do this freehand on camera, it's not going to go well. So I'll do this off camera and then we'll do the third function. Okay, then our third and final part of the function is f of x is 5x minus 25 for x greater than or equal to 4 less than or equal to 5. So, substituting x in, x equals 4 in, we're going to get 5 times 4 is 20, minus 25 is minus 5. So, that was the last coordinate point of the last bit of the function, which is also now drawn down here. So it was a hollow dot. We don't need to worry about that though, because in the third bit, it's allowed to equal it. So I'm happy I get to do some colouring in. Okay, and then the very last bit of this monster question, we need to substitute in x equals 5. So when x equals 5, f of x is 5 times 5, 25, minus 25, so 0. So our last point is 5, 0, which lives here. Now it's an or equal to inequality, so it's a nice colour dot. So we just then need to join up these two final points with a straight line. Like that. So there's our lovely piecewise function in all its glory. That took a long time. Okay, and 11b is asking us to state the range of f of x. So the range of a function is basically the y values that it can take. So our minimum value, if we go back, was this chap down here at minus 5, and our maximum value was this guy up here at 7. So the range of our function is minus 5, it's less than or equal to f of x, which is less than or equal to 7. That's the range of our function. Okay, 12a. Factorise fully 75 minus 3x squared. So first of all, we've got a common factor of 3. So we can write this as 3 lots of 25 minus x squared, like that. Now, this 25 minus x squared is an example of a difference of 2 squares. So this is going to factorise to 3 lots of 5 plus x times 5 minus x, like that. Jobs again. 12b, simplify fully. 3n plus 1 squared minus 3n minus 1 squared, good times. Okay, so the trick to a question like this is just take your time, be very careful. So 3n plus 1 squared is going to give us 9n squared plus 6n plus 1, and then we're subtracting. Now I'm going to use brackets here. Now 3n minus 1 all squared is going to give us 9n squared minus 6n plus 1. Now remember though, that stuff is all being multiplied by minus 1. So we got 9n squared plus 6n plus 1 minus 9n squared plus 6n and then minus 1. So a lot of this cancels out. 9n squared minus 9n squared cancels out. We've got 6n plus 6n, that's going to give us 12n, and then we've got 1 minus 1, which cancels out. So our answer is just 12n. Jobs again. Okay, question 13. We want to simplify this bad boy. So before we even consider doing the multiplications and divisions, we want to factorise anything that we can. So 8a, we can't do anything with that. 3a plus 6 though, we can write that as 3a plus 2, like that. And we're multiplying that by, well, 5a plus 10, we can simplify that to, factorise that to 5 lots of a plus 2. And then the bottom, we can't really do anything with 3a squared. But what we can do before we worry about this third fraction is combine this and simplify a little bit. So up on top, 8a times 5a, 8a times 5 lots of a plus 2 would be 40a times a plus 2. And then that's all over. 3 lots of a plus 2 times a squared is going to give us 9a squared. 9a squared lots of a plus 2. So at the moment we have a common factor. We've got 2 common factors. We've got a common factor of a that we can cancel out and a plus 2. So the a plus 2's, let's cancel those out first of all. Then we've got 40 a over 9a squared. So then we've got a common factor of a, so we've now just got 40 over 9a, like that. So now we can carry on with the question. Let's change colour. So, what have we got? I've forgotten. We've got 40 over 9a. Okay, so remember when you divide by a fraction, you flip him over and multiply by him. So if we're dividing by 4 over 15a cubed, we're actually multiplying by 15a cubed over 4. So if we do that, well, we're going to get, let's just write it as 40 times 15a cubed over 9a times 4. And cancel out any common factors we can with it written like this. So, there's a common factor of 4 between 40 and 4. So we can divide the top and bottom by 4, which is going to give us 10 times 15a cubed over 9a. There's a common factor now of a. We can divide that away, we'll get 10 times 15a squared over 9. And then finally, there's a common factor of 3. So we can go down to 10 times 5a squared all over 3. And then finally, that is 50a squared over 3. Jobs again. Okay, question 14. So the line y equals ax plus b is perpendicular to the line x plus 4y equals 74. So that's going to be important to us, I think. Remember the gradients of perpendicular lines multiplied together to give us minus 1. So we're told the lines intersect at the point where x equals 2. And our mission is to work out the values of a and b. Okay, well, first of all, we need to get the gradient of this guy. To do that, we need it in the form y equals mx plus c. So, if we subtract the x, 4y is 74 minus x, divide by 4, y is 74 over 4, whatever that is, minus 1/4 x. So the gradient of x plus 4y equals 74 is minus 1/4. So, if we say that's our line, let's call him line 1, then line 1 has a gradient m1, which is minus 1/4. So, again, as I said before, the gradients of perpendicular lines multiply together to give us minus 1. So, m1 times m2 will call our second line L2, that has gradient m2. We know m1 mt is minus 1. Now we know m1 is minus 1/4, so minus 1/4 times mt is minus 1. So to get the gradient of our second line, we divide -1 by -1/4, which gives us positive 4. So what we've actually just done there is we have worked out the value of A. Remember, the equation of our line is y equals ax plus b. So A is the gradient, A is 4. Yay. So the equation of our line is now y equals 4x plus b. Cool. Now then, we are told that these two lines intersect at the point where x is equal to 2. So this point here. So what we can do from that bit of information is work out the y coordinate. Then when we do that, we can work out b. Lovely. So we're going to substitute x equals 2 into x plus 4y equals 74. So if we do that, we get 2 plus 4y is equal to 74. Take away the 2. 4y is equal to 72. And then if we divide that by 4, we get y is equal to 72 divided by 4 is 18. So the y coordinate here of the intersection point is 18. How does that help us? Well, that tells us now a set of coordinates on our line y equals ax plus b. So we now know when x equals 2, y is equal to 18. So if we substitute that in, we get 18 equals 4 times 2, which is 8, plus b, take away the 8, we get b is equal to 10. There we go, guys. Jobs again. Okay, question 15. We want to rearrange w equals 8x minus y over y to make y the subject. So, first problem, we got y on top and bottom of a fraction. We need to multiply through by y. So we'll get wy equals 8x minus y. We then need the y terms on the same side. Add the y plus wy equals 8x. I used to get here and then stumble. The trick now to turning these two y terms into one y term is to factorise. So we can factorise the left to y times 1 plus w equals 8x. Then divide by 1 plus wy equals 8x over 1 plus w, like that. If you want more examples on those, guys, I have a video called Rearranging Algebraic Fractions. Check that out if you want more examples. Question 16, so this is going to be the final question for part 2. We'll finish off in part 3. So, nice little one. We've got a is equal to 3 to the power of minus 2b. We want to circle the expression for 1 over a. So 1 over a is going to be 1 over 3 to the 2b, which in indices speak is 3 to the minus 2b. So there's our guy. B is telling us y equals 5 to the power x. Circle the correct expression for 25y. Well, 25y is 25 times 5 to the power x. 25 is 5 to the power 2. So we got 5 squared times 5 to the power x. And we add the powers, so we get 5 to the power x plus 2. So where's that? There he is. Okay, and then part C, w is equal to 2 to the power of m. We want to circle the expression for w cubed. So w cubed is 2 to the power m cubed. Remember then with indices separated by brackets, you multiply them together, so we get 2 to the 3m. Which, where's he hiding? There he is. Okay, I think that's the last part. Yep. Okay guys, that's part 2 done. Hope you're finding these useful. Don't forget to give us a thumbs up. Get subscribed to the channel. It's great fun.